Hello everyone. In this session, we are going to see the concept of excitons, which is generally observed due to the sunlight absorption by the electrons in the conducting material, which is responsible for the photo-generated electrons and the holes, and which is associated with the quasi-particle, which form due to sunlight absorption. So basically, we starts with the what is meant by exciton. So the exciton is nothing but the quasi-particle that forms when an electron in the semiconducting or the insulator absorbs the energy, typically in form of the light, as we discussed, like the sunlight, and get excited towards the higher energy level, most probably the conducting level, and by leaving the holes at the valence band, or we can say that by leaving the holes at its original position. So what will happen? This creates a bound state of the excited electrons and the holes, which are attracted to each other due to electrostatic forces, forming the excitons. So these excitons are nothing but the neutral, and they can transport the energy through material without carrying an electrical charge, making it more convenient or important in the optical processes such as the photoluminescence, solar cells, as well as the light emitting devices. So, how exactly excitons can be generated? That can be seen through these schematics. So, whatever the electron present in the semiconducting or the insulator materials, it able to absorb that particular sunlight or the light. So, what will happen? This electron gets excited towards the conduction band by leaving the holes at its original position. We can say that the valence band in case of the semiconductors. So this particular state where the electrons and holes are attracted towards the each other, so that forms the particular state which is known as the quasi-particle. So this is nothing but the excitons, and which is applicable for the different optical processes as discussed at the earlier slide. Okay, so regarding the types of excitons, there are several types, starting from the Frankel excitons, linear Mott excitons, charge transfer excitons, dark excitons, bright excitons, as well as bi excitons. These types are basically on the nature of the bonding between the electrons and holes, and the application where it is mostly applicable. Okay, so in concern with the Frankel excitons, in which electrons and holes are strongly bound with each other, and it is mostly common in case of organic materials or the organic LEDs. Okay. In case of another exciton, that is Vanier Mott excitons, in which electrons and holes are weakly bonded with each other, which is mostly found in case of inorganic semiconductors. Third one, that is charge transfer excitons, which involves the charge transfer across the region, and typically it is found in case of the hybrid samples, that is organic plus inorganic hybrid materials. In case of dark excitons, the excitons which cannot readily recombine and having the spin antiparallel configuration, they are said to be the dark excitons. Example, it is mostly observed in case of the semiconductors like quantum dots or the two-dimensional semiconductor materials such as molybdenum disulfide, having the indirect band gaps. While the bright excitons, the excitons which can relatively recombine and showing the spin parallel configuration, and it is mostly found in case of the 2D materials having the direct band gap. Okay, and last one, that is bi-excitons. It is nothing but the a pair of excitons which bound with each other. So this is about the types of excitons and what is meant by excitons, and why it is applicable for the optical processes. Thank you.